Now, in the last video, I showed you an interactive application to view the multidimensional dataset. Now, in this video, I'm going to show you the code behind the application. Now, it is called Previewer, which is on my GitHub. And if you open the browse code, and then you can see some files. I've included a license and a short summary of the idea of the code. So the main function is still the app.r. It might seems a little bit messy, but it still follows the RStudio Shiny application templates, which is that you load the library and function first, and then you use a fluke page called a object called UI. Then you use and then you define the server as a function of an input and output. So the UI part is just the user interface part, and you can see multiple panels, and this defines the page layout. It has rows, columns, tab-set panels, and then multiple things, and you can easily find that in the documentations. Now, one interesting thing is that you could make something called UI output, as we see in line 83 and 84 here. It says column 2 UI output second selection and second selection 2. Now this part is because some output is some of the selections are dependent on the dataset input. For example, you may want to select the name of a variable to be mapped on different the name of the variable to be mapped on each axis. For example, you pick a variable from the dataset to map onto the x-axis. Now, the name of the variable must come from the dataset. This is why this is we have an entire UI of output which is reactive to the input logic. So you can see it enables you to include upload file and tune different variables here. Now the server function has different reactive objects. So as you see, reactive data frame is a reactive things together data frame, which is not very surprising. Reactive method, which is not very surprising. The thing is, you can use reactive data frame, reactive method to create a different output object. For example, output summary. It just creates a summary of the reactive data frame. Now I use the creative reactive data frame bracket to refer to the reactive data frame above. We're just calling this reactive function. Actually, the reactive function is returning a function to a reactive data frame. That is one of the technique you can use in the application. And output summary, outputs overview are just a subcomponent of the thing called output, and you don't have to really worry about it because the render print, render tables stuff does all those things for you. And I've also defined something called reactive variables, which is to detect all the variables in the data frame as a vector, so you can know what variable does this system consist. What variable does the system include? Now the output selects second selection is just to use the property of the data frame to get an idea what variable you can put into each axis, which is not very surprising. Second selection 2 it's quite similar. You can use a model to you can use some target model. Uh, for example, like the predictive model must have a target variable. Like what variable do you want to predict out of other variable? This is the part that's the selection. So this part is still UI, but the next part, the output plot, it's actually doing the real stuff because you see it's using the reactive data frame that we defined above to define dataset, and then we handle the dataset safely. So because what I mean safely is that we must be systematic when we solve when we deal with the data. The data here might not be variable; they may be constant, and it's going to be some problem if you fill constant into a variable because there's like zero variance, and you see it safely detects that. And the same idea with missing values. You can ignore the missing value, or you can use the fill with AVG to fill it with at the average or the mean. You can also do cluster the variable, which you could add the function, or I could add the function later to use the caret function to use some clustering techniques to deal with missing values. And these are just normal things. Invariable, number of variable, var names, variable names, and var types, types of variable, dataset original num. So dataset original num is the part of the dataset that, or only selecting the columns that's originally numeric, because even for some columns are not numeric, you can convert it to a numeric variable because you could do as numeric to convert factors as 1, 2, 3. So, for example, if you have a factor of 3 levels, if you have a species with 3 species, you can use numbers to represent the 1, 2, 3 species, right? So it converts to numbers. The point of converting this to numbers is that it's good for plotting and calculation, and for some packages, not for all of them, because if you use tidyverse, it deals with all the factors automatically. Okay, so this is pretty much the processing. You care about x variable, color variable, y variable, z variable, and the variable you want to map on shape, and probably you want to group the model by some variable. I've used 2 variables as the maximum groups that you consider. And and then I can fill this into a GG or grammar of graphic object, or but I'm actually parsing an expression here, so it's looks quite nasty. Which, well, can be fixed later. You could find some clever things with that. So if the method is preview, probably you are not taking a dataset into the function. Probably gonna have a time series, or probably going to have a matrix. So it kind of deal with that, but it kind of not deal with that, because this application itself is only for multi-dimensional tidy dataset, not for those other things. So let's jump into the case when it is a proper dataset. So from here, you could really see the kind of process we can deal with data. We could do exploratory analysis. We can do data transformations, which lower the which consider the inner relationship between different objects, different variables, and you can also group it by different groups, or you can color them and distinguish them. Then you might be interested in doing some statistic tests to eliminate different hypotheses and validify different considerations for the data. For example, is it true that if I assume this would be right? So it does this. So the you can do t-test like different statistics. For example, t-test analysis of variance for 1D for 1D distribution. You can also do 2D, but so far I have not included many things for 2D. And you can do multiple, like you could do PCA, so principal component analysis. This is also the part of the code that does it. Uh, and also you can fit multiple models by groups. But this, I mean, you can have two variable grouped by another two variable, and you can have a like a four-dimensional relationship. But you don't really have to do this with four-dimensional model. For example, you might have a 2D model from one variable to another variable, and then you uh, group the group the relationship between the first two variable by the other two variable, right? So this is kind of what tidyverse and ggplot does. I have not included the many model part, but I have included the multiple uh, like the grouping by two variable for the relationship between two variable visually using ggplot. So this is also the part that does it. And also, since for all the ggplot part, we already specified what a g is by using the gg set as expression. So this is converting to our group variable, shape variable, x and y variable selection to uh, to a GD object, and so this comes almost automatically. The next thing is using Caret to do some predictive models. So predictive model can be like different from the purpose is kind of can be different from explanatory models, but you don't really want them to be black boxes. So the point of including a lot of complicated model in the first start is that you can evaluate a upper level for the let's say you could include you could estimate an upper limit of the predictability. So if a very complex, if several multiple like complicated model when they are tuned with cross validation shows that something can be predicted by some percentage. Maybe the variance is all that you can get. Then you could try some simplified model and maybe try some grouping and linear relationship to interpret the data, and then build some more robust explanatory model and which may be more reliable and have more physical meanings. So this part I included the model called from Caret and C50, neural net, tree bag, and also other things. You can plot two things. You can plot the model performance, because it's the back control thing, the back control object returned by the train function of Caret. It deal with the performance of a model with different training parameters, and the performance is not the pure performance on the training set, but the package, the Caret package, actually does uh, do the cross validation for you, so its performance is cross validated. Or you could also choose other means, not cross validation, but also other ways of like bootstrapping, leave one method for for validation. But I think CV cross validation is k-fold cross validation is kind of a more commonly used and also computationally not computationally expensive. Okay, so for the last part, really haven't done much yet. This is a 3D pairwise plot. So sorry, I should mention the 3D plot first. 3D plot, and it's restricted to scatter because I don't want this to be kind of too complicated, and you could specify XYZ variable and a color variable. The color variable can be a a continuous variable or non-continuous variable, and they also works. The next part is the data. The output data is actually the consideration of the model instead of just showing plot, because only having a plot is kind of a not really good way of doing statistic. The if I can show the plot with the model and with those parameters, it could be more considerate and more like a professional statistical report. So for different components of the plot, I also included different models. For example, you can use for example, when viewing the principal component analysis, I can show you the PCA, and the structure of PCA show you the angle, the components of the lambda values for the how much does one variable contribute to the whole variation. For the explanatory model, you as for the for the pairwise plots and the pairwise linear correlation, I can show you the data of the correlation of the different variable, and also the using the same norm function, I can show you a neat pivot table. For 1D histogram, I can show you a summary of that and the skewness of that, maybe some more. But if you have a 1D histogram and you use a method to group it by another variable, it can generate a pivot table for you, which is kind of nice to compare the group-wise summary, right? So for 2D model, I'm planning to do similar things, but I haven't done much yet. Okay, so for all the predictive model, it just to show the model inside and the model parameters, right? And here's come the interesting part. I can actually show you the code for the reason that let's say I can actually show you the code because I have all of the code, and also when you click those things, it's actually doing this kind of parsing, deparsing, and evaluations. So actually, in most I made sure that it most worked in most of my function, but I haven't completed all of the function yet. Hopefully, if you have new models, you can register the model into the user interface, and also you can try to tweak it a little bit to slightly make it better and submit a pull request. If you have any bugs to report, feel free to create a message in the issue block. And if you want a tutorial, please check out the previous video. Okay, thank you.